Look at it head on, and something feels off before you can even explain why. The fuselage is too big. Not proportionally big, actually physically wrong, like someone inflated the top half of the aircraft until it stopped looking like it belonged to the bottom half. The cockpit has been pushed down and to the side, tucked beneath the swollen upper fuselage like it got shoved out of the way. That something bigger is the entire point of the aircraft. This is the Airbus Beluga XL. Every detail that makes it look like a mistake is actually a deliberate answer to one specific, genuinely bizarre problem. Airbus builds its airplanes in pieces, in different countries thousands of kilometers apart, and somebody has to fly those pieces to the final assembly. Wings built in Wales, fuselage sections built in Germany and France, tail assemblies from Spain, all of it needing to arrive at assembly lines in Toulouse and Hamburg, on a schedule tight enough to keep production running without delay. You cannot put an airplane wing on a truck and drive it across borders. You cannot put it on a ship and wait weeks. Airbus needed something that could fly enormous, oddly shaped, genuinely irreplaceable aircraft components between factories, fast, safely, and often. The Beluga XL is the answer. And to understand why it looks like it swallowed a smaller plane whole, you first need to understand exactly how strange the problem it solves actually is. Most people assume an airplane is built the way a car is built. One factory, one assembly line, finished product rolls out the door. Airbus does not work this way, and never has. Airbus is a consortium, formed in 1970 from aerospace manufacturers across multiple European countries. That origin is baked into how the company builds every aircraft it makes. Wings for most commercial jets are manufactured in Broughton, Wales. Fuselage sections come from factories in Hamburg, Germany, and Saint-Nazaire, France. Other major components come from facilities in Spain. Final assembly, where all these pieces actually become a complete airplane, happens primarily in Toulouse, France, and Hamburg, Germany. This arrangement exists for reasons that have as much to do with European industrial politics in the 1960s and 70s as with engineering logic. A consortium built from national industries needed to spread manufacturing work across member countries to justify the political and financial support. But the practical consequence has remained constant. Airbus needs to move enormous, custom-shaped, expensive components across international borders, repeatedly and reliably. In the earliest years, this meant surface transport, trucks and ships, moving components on journeys that could take days. As production rates increased, this became a genuine bottleneck. You cannot build airplanes faster than you can deliver the parts to build them. And surface transport for something the size of an A350 wing section is neither fast nor flexible. The original solution, dating back to the 1990s, was the Beluga, officially the Airbus A300-600 ST, a modified version of an existing passenger jet. It featured a dramatically enlarged upper fuselage, built specifically to carry oversized components. It worked. It solved the problem for decades. Then Airbus's production rates grew past what the original Beluga fleet could handle, particularly for larger components of newer aircraft like the A350. That's the specific gap the Beluga XL was built to close. The Beluga XL is based on the Airbus A330, a larger, more modern airframe than the A300 that the original Beluga used, and its cargo hold is proportionally larger to match. The cross-section of the cargo bay is approximately 30% greater in volume than the original Belugas, sized specifically to accommodate complete A350 wing sections, something the older aircraft couldn't manage. Building an aircraft with a fuselage this dramatically reshaped required solving structural problems that don't exist on a conventional airliner. A normal fuselage is roughly cylindrical, and that shape is structurally efficient. The tube distributes pressurization loads and aerodynamic stress evenly. The Beluga XL's fuselage abandons that efficient shape entirely, ballooning outward at the top to create the cargo volume needed, while the lower section retains something closer to the original A330 structure to preserve the wing attachment points and landing gear mounts. This asymmetric shape creates structural loads that a conventional cylindrical fuselage never has to manage. Airbus's engineers reinforced the airframe extensively in the transition zones, using additional structural framing to handle stress concentrations. The cockpit's unusual position, pushed down and to the side, isn't a styling choice. It's a direct consequence of the cargo hold's shape. The enlarged upper fuselage needed to extend as far forward as possible to maximize usable cargo length. Moving it below the cargo hold solved the space problem, but created a new one: reduced upward visibility for the pilots. Instrumentation and camera systems are specifically designed to help compensate for this limitation. The bulbous upper fuselage is shaped the way it is because engineers had to fit a specific cargo cross-section into an existing airframe. Every strange curve is the direct visual signature of that compromise. Loading cargo onto the Beluga XL is unlike loading almost any other aircraft in the world because the entire nose section of the plane opens. The cockpit and forward fuselage swing upward on a hinge, exposing the full cross-section of the cargo hold from the front. This is necessary because the cargo itself, wing sections, fuselage barrels, tail assemblies, often has dimensions that make loading through a conventional side door impractical. An A350 wing section is long, oddly shaped, and structurally delicate in ways that require careful, straight-line loading, rather than maneuvering around interior corners. Specialized ground equipment moves the cargo into position using a system of rails and hydraulic lifts built into the loading facilities at each Airbus site. Rather than relying on the aircraft's own systems to do the heavy lifting, the component is guided in on its transport cradle. Once secured to the internal cargo restraint system, the nose closes again. For a full wing section, this process can take the better part of a day. This includes the preparation and verification steps required before the aircraft is cleared to fly. The Beluga XL fleet operates on a continuous rotation. A single aircraft might fly from Hamburg to Toulouse carrying fuselage sections, then reposition to collect wing sections destined for final assembly elsewhere. This constant shuttle service keeps Airbus's entire multinational production system functioning as a single coordinated operation, rather than 5 disconnected factories. Without this capability, Airbus's decentralized manufacturing model simply wouldn't work at modern production rates. The strange-looking aircraft is not a curiosity. It is one of the load-bearing pieces of infrastructure that makes the entire business model possible. 6 Beluga XL aircraft currently operate in Airbus's fleet, alongside a small number of the older, smaller Beluga ST aircraft still handling lighter-duty transport work. Together, they form a transport system that most airline passengers will never see, never think about, and never realize exists. Despite the fact that every Airbus aircraft they've ever flown on almost certainly had major components carried by one of these strange, swollen-looking planes. This is a common pattern across large-scale engineering. The machines that make everything else possible are rarely the machines that get attention. The Beluga XL doesn't carry passengers. It doesn't set speed records or altitude records. It exists entirely inside Airbus's internal supply chain, invisible to the public. The aircraft's continued development reflects this quiet but critical role. As production rates for the A320 and A350 families have increased to meet global demand, the Beluga XL fleet's utilization has increased correspondingly, flying more hours on tighter schedules than almost anyone outside Airbus's logistics division tracks publicly. Stand at the edge of a runway at Hamburg or Toulouse and watch a Beluga XL on approach. Its bloated silhouette unmistakable even from a distance, and you're watching a machine shaped entirely by function, with every strange proportion existing for a specific, necessary reason, carrying a wing or a fuselage section that will, within weeks, be part of an aircraft carrying hundreds of passengers who will never know how it got there. That's the story the Beluga XL tells. Sometimes the strangest-looking machine in the sky isn't strange at all. It's just honest about the problem it was built to solve, even when the shape that solution demands looks like nothing else that has ever flown.